Right. So first of all, I'd like to welcome everyone to the SEPM's Distinguished Scientist Interview Series. It's an honor and pleasure to introduce you today the 2024 winner of Francis B. Shepard Medal of Recognition and Excellence in Marine Geology, Dr. Duncan FitzGerald, who is a professor and as an environment department, Boston University. Congratulations, Dr. Duncan, for this amazing achievement. My name is Ahmed Mugazi from Egypt, a PhD student at the University of Iceland. My research focuses on environment, climate over the early Pleistocene in Northeast China. And I use a combination of sedimentology and micropaleontology and geochemistry. In our interview today, I have a list of a few questions that I would like to go through with Dr. Duncan to learn from his long experience in geoscience. And I suggest to start with an introductory question of if you could give us a brief summary of your path to geoscience, like when and how did you discover your passion in geoscience?
Sure. First of all, let me just say that I'm very humbled by receiving the Shepard Medal. I can't say that I never wanted it, but the day it came, it was very, very humbling. Anyway, I first went to University of New Hampshire to study geology with the intent of going on to get my master's in geological oceanography. So I minored in math and took a large number of chemistry and physics and biology courses to prepare myself for oceanography. I did my master's degree at Texas A&M, working with Arnold Bauma, who taught me all about turbidites. While at A&M, on the advice of a roommate, Brady Elliott, I took a course in coastal engineering with Bob Sorensen, who went to A&M from the Army Corps of Engineers. That course changed my life. He introduced me to waves and tides and sediment transport, tidal inlets, and the effects of storms. We did field studies at Brown Cedar Cut along the Texas coast, and we used flumes and wave tanks at A&M to get our hands-on understanding of the movement of sand by tidal currents and waves. It was that course that completely changed my direction. Originally, my goal was to get a master's degree and then enter the oil industry. But all that changed when I discovered my passion was truly in coastal processes. To pursue that interest, I went to USC to study with Miles Hayes for my PhD. Miles Hayes was a giant in the field, but you didn't just learn from him. He had a large research group who educated you as well. One of those people in particular was a man by the name of Dag Numedal, who was a very important mentor to me. Both Miles and Dag gave me an understanding of coast and continental shelves from a worldwide perspective, and they taught me how to look at all facets of the area and their impacts on processes, morphology, and stratigraphy. They said to me, take off your blinders and look at everything that affects your study area. Graduating in the late 1970s, I traveled to Boston University, and I've been there ever since.
Okay, that's a nice journey, Duncan, and a lot of discovery of the science and a lot of trying to get to the discipline that you fall in love in. And then I guess this is typically in academia. Then, yeah, we didn't realize that how we cannot narrow down our field into a specific side until we explore many things. So that's awesome. I'm gonna move on to the second question. What are you most proud of in your career? Like maybe in a publication, maybe in a teaching, maybe in a supervision of students. Like what are you really most proud of?
I guess what I'm really most proud of is able to attract outstanding graduate students and be a small part of their success. I've also collaborated with many bright colleagues, many of whom have become my dear friends. And I also put on that list maybe making several important discoveries that have furthered our understanding of coastal processes and shoreline evolution. These would include providing a greater understanding of tidal inlets, ebb tidal deltas, and mechanisms of inlet sediment bypassing, and how these processes affect barrier island erosional depositional trends and the overall morphology of barriers. I've demonstrated the importance of spring freshets in controlling sediment transport in major New England estuaries. Now, many people believe that estuaries are long-term sediment sinks, and many are. But in New England, melting snow coupled with high precipitation causes overland flow due to the frozen ground. This water enters brooks, streams, and eventually major rivers. It's during these events that flow in the estuaries becomes unidirectional, despite the 3-meter high tidal range in the region. The freshwater flow completely displaces the saltwater flood tidal prism, and discharge can increase by more than an order of magnitude. It is during these events that the sediment is flushed from the estuaries and actually can be transported from the mouth to nearby beaches and barriers. I've also shown that the presence of barriers themselves in the Gulf of Maine, as well as low stand deltas, can be traced to major river systems. As the ice melted and retreated northward, and the drainage systems once again were reestablished, river-sourced inland sand reservoirs consisting of sediment that was originally deposited during deglaciation. This sediment, in turn, came from the weathering of nearby saprolitic granitic plutons. So the barriers and low stand deltas in the Gulf of Maine can actually be traced to a number of granitic plutons. That's pretty neat. Also, I presented a model of the evolution of barrier coasts in a regime of accelerating sea level rise. It's called the runaway barrier transgression, and envisions wetland loss due to accelerated sea level rise, resulting in widespread conversion of marshlands to open water in the back barrier systems. This in turn causes an increase in tidal prism, which produces larger sized tidal inlets and enlarging ebb tidal deltas. At the same time, changes in the back barrier hypsometry lead to flood dominant tidal inlet channels, causing the import of sand. All of these processes are at the expense of intervening barrier island sand reservoirs. Under these conditions, erosion and eventual transgression of the barrier are inevitable. I've also made contributions to our understanding of the evolution of southern Brazilian coast, where sea level has fallen during the last 6,000 years. With the aid of my colleagues Bill Cleary, Chris Hine, Ilya Bunevich, Antonio Klein, we discovered the double the double Pleistocene and Holocene high stands that are sitting side by side and separated by only several hundred meters. We also demonstrated how basinal infilling occurred as sea level fell and how this led to the development of beach ridge plains and chenier systems. My group has also demonstrated the importance of storm events in delivering sediment to marshes, both in northern latitudes by way of ice rafting during extratropical cyclones, and in southern latitudes during hurricanes. Storm processes increase the resilience of marshes, particularly in the future regime of sea level rise and greater storm magnitude and frequency. Most recently, I've been working with colleagues Yanis Georgiou at the Water Institute in New Orleans, Zoe Hughes at Boston University, and Kevin Hannigan at Moffitt Nichols, modeling sediment transport at tidal inlets and in back barrier systems using different sea level rise scenarios and under different storm conditions. We've shown that inlets import sand under different sea level rise scenarios and under most storm conditions, which collectively, again, deplete barrier islands of their sand reservoirs.
Okay, that's amazing, Duncan. That's amazing. I guess that's obviously reflected in your long record of papers, published papers, and also it sounds that you made a major influence and impact into the shallow marine sedimentology. Awesome. Also have a question here, like, yeah, I mean, the question here tells, like, if you face any challenges or setbacks that, yeah, like, it turned out to be like valuable experience for me, for you, like, what is it?
Well, I think we all have experienced setbacks, and we try to forget those. But I think everybody, one time or another, has been questioned as the relevancy of their science. I remember one chairman once telling me, you know, Duncan, you're just another Miles Hayes. I didn't say anything back to him, but I do remember thinking, what a great compliment.
Okay,
Also,
yeah.
as scientists who must rely on federal funding to support your research, getting proposals turned down is part of the process. And likewise, seeing your papers submitted for publication being sent back for more editing. One must attain some thick skin and a resiliency to keep rewriting and trying again. You simply have to learn how to deal with defeat.
Okay, yeah. But also in term of the, of course, you have witnessed COVID time, for example, and this is like the time that it stops everybody to not go to the field or like to do some experiments outdoor. Is it also one of the challenges that how you manage like the time of COVID, for example?
So say that again, that last sentence. I didn't hear you.
Yeah, I mean, like also I was wondering like during the COVID time, like we always need to go outside to grab some like samples or to do some outdoor experiments in term like in your field, like you of course you observe the coast changes and to do some field work. How you manage the time? Do you consider this as a challenging as well?
Well, during COVID, it played right into my hands because at my very core, I'm a field geologist. That's where you learn. So having all that extended time, not being at the university, not necessarily being behind my desk, rather having that time to go out in the field allowed us to collect a lot more data and conduct a lot more experiments.
Mm-hmm. Yeah, yeah. All right. Also here, like, do you, for example, like regret something that if you go back in time that you would have done it differently? Like, you will change the procedures, you will go in you would go in a different path, or?
I think I'm very pleased in the direction I go, but I believe, like most people, as you progress through your career, you become more proficient as to how best to accomplish your research and become more aware as to what scientific questions are best pursued. Initially, you're
Yeah.
trying to procure funding and support your students any way you can. So sometimes you pursue some studies that aren't real science killers. With time, you learn how to optimize your efforts and your studies. To go back in time, I believe there are some areas of research that I would not have followed. For example, when I first got to BU, I decided to set up a statewide beach profile network.
Mm-hmm.
Anyone looking at the length of the Massachusetts shoreline and the distance from Boston University could definitely see that it was an unrealistic goal. And what did I learn? That beaches erode during storms and build back up during fair weather conditions? I'm pretty sure that that was already known. It was probably not the greatest use of my time. However, it did introduce me to the Massachusetts coast.
Mm-hmm. 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 Yeah, yeah. I guess we sometimes plan something in advance and then within the way, like we have, found out that this is, the right way that we've been through. But yeah, maybe at the beginning we have been doubting it a bit, but then like, yeah, like by time we see things in a different and clear way, maybe. Yeah.
I think with time, you really begin to ask the question, is this study going to really further our understanding? And that's what's the defining line with me.
Mm-hmm.
Are we really going to learn something? Is this just another site-specific study, or are we really pushing science further?
Mm-hmm. 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 Yeah. Okay, I mean, most of the previous question maybe was about your career path, but maybe now like go into something more into your life. So we want to know also how you manage your time, like how you could maintain your like work-life balance, for example, which is, I know that it's really hard in academia.
Yes, particularly when you first start out and you've got to write grant proposals, write lectures for class, mentor students, go to meetings. It's very difficult to begin with. But I must say that first and foremost, my family and extended family always come first. And we spend a lot of time together during every holiday, such as this past Sunday, in which we had a small gathering of 20 people at our house celebrating Easter. During the summer, my whole extended family gets together every weekend at our family cottage at Popham Beach, Maine. This cottage has been in the family for 102 years. My great grandfather purchased it for $800, and it's been with
Wow.
us ever since.
Uh-huh,
But
uh-huh.
frankly, I need little sleep I love my science, and relaxing for me is doing field work, writing, or doing outside chores. My wife calls me the Energizer Bunny, and I rarely sit still.
Okay, yeah. I mean, that's lovely. And happy Easter, like, by the way. All right. So also, like, have you been in a situation that you consider like some skills that that helped you a lot and it became essential, but you didn't expect it, like it's unexpected skills, and then like you found, no, this is really essential and it helped you a lot at your job, like something that you never anticipated, for example?
Yes, I'd say tenacity. In playing sports, I learned to never give up. I mean, it can be set point for the opposing doubles players, and I'm going to fight to the very end. Also, with growing up with a competitive twin brother, certainly helped in that respect as well. Sometimes I feel a little bit like a baseball player. If they get a hit 1/3 of the time at the plate, that's considered extremely successful. That means you're failing 2/3 of the time. Likewise, if you have 1/3 success in your grant applications, that's a pretty good average as well. Basically, having the ability to look past your defeats and keep submitting proposals and dealing with critical reviews to eventually achieve success is an important attribute, and one I learned in part from playing sports.
Do you also like have to like to suggest or like to recommend the young geoscientists about like a set of skills that are really essential in our field, like maybe some softwares, maybe some field methods, maybe some like in terms of critical thinking, writing stuff, like do you recommend some?
Yes, going to the field, you mentioned both of these. I think going to the field and looking at active processes is an essential ingredient in any successful career in geosciences. And also writing, having a skill to be able to write is something that you should write every day. I don't care what you're writing, but try to write every day. That's how papers actually get written. You don't set aside a block of time. I'm going to write a paper in 2 weeks. You actually get it done maybe over a month's period of time, a couple hours here, a weekend here, and so on. So writing and getting out in the field, I think, are two very important skills. And yes.
Yeah, that's awesome. Okay, so I have here also a question about I mean, I guess it happens to everyone. Like you decided to not go. Like, have you faced like, or have you been in a day that you didn't like to go to work, for example, and you just like have a day off, and you are not in a mood to work, or do you always like enjoy what you do, or you didn't think a lot about like changing something? Yeah.
I'm working on so many neat things. I enjoy going to work every single day. It's really not work for me. And typically I get to BU around 6 o'clock. I beat the traffic that way. And the only thing that interferes with that schedule is our summer cottage in Maine, where I take off maybe on a Thursday afternoon.
Yeah.
That, and I'm not crazy about faculty meetings. I could skip those days at BU as well. Hope the chairman is listening.
Yeah, I mean, I can confirm that. I remember that when I emailed you like during the weekend, and then I apologize about sending email in the weekends, and you told me that, yeah, you even like to work in a weekend. So this is actually a sign of, or indication like how you love your work. Okay, this is kind of a general question, and we want to get your thoughts on that. So have you noticed, like in your opinion, have you noticed like a big change or a little change in the geoscience over the years? And also, how do you see that geoscience and research is gonna evolve in the upcoming years, for example?
Obviously, being in geosciences for as long as I have, I've seen lots of changes. However, about 15, 20 years ago, I realized our coastal science was going to be transformed by numerical modeling. Luchess at UNC, Westerink at Notre Dame had already written ADCIRC. Later, Chen at UMass South Dartmouth wrote FECOM, followed by scientists at Deltaris who wrote Delft 3D and SWAN. One-line models were coming out of Duke. Magnus Larson at Lund University put out S-Beach, and the list goes on and on. These models provide us with a means of examining and scaling different parameters, isolating important parameters, and predicting future scenarios. However, the models are only as good as the input data, and predictions are only reliable if the model can actually capture real-world processes. And while I fully appreciate the significance and usefulness and use modeling myself, in my opinion, there are far too many young scientists who are doing research, i.e. writing papers, that rely entirely on mining existing data to run their models. And many of their studies are very broad-based, and because they cover entire continental coastlines or the entire world, people think they're great, and agencies, managers, and planners apply them indiscriminately. However, due to scaling issues both temporally and spatially, these models may not be appropriately characterizing a specific area or particular conditions. We still should have numerous field studies that test these models and their findings. Also, understanding the processes and morphology that we learned by being in the field and measuring different parameters are lost to many of these modelers who are anchored to their computers. They lose the power of inspection, the ability to ask the question, do the findings of these models really make sense? Our scientists are best trained by first understanding the processes they see operating in the field. In that way, they're much better prepared to apply numeric models.
Okay, yeah, that's great. I also like how you see the technology. You know, like you work in a physical geology basically, so you monitor some processes and around, like along the coasts, for example, and you know, there's like many remote sensing applications and also GIS softwares, and also with the machine learning. How you see those like technologies kind of affected the coastal sedimentology or the coastal marine science in general?
Well, I think, like I just mentioned, there is so much data that you can simply mine from NASA, from other satellites, existing information that is published in papers, that a lot of people just use that data to go out and input that to their modeling programs, without having the ability to really truly understand the processes that they're modeling, because they've never seen them. They've never seen sand waves that are moving downstream in a river system, or a beach recovering after a major storm, or on any number of processes. So I think it's imperative that we get our young scientists, who are the next generation of modelers, to actually go out there and view coastal processes from a field standpoint.
Also, like if it comes to the writing, like also there is now like artificial intelligence like helps the researcher like to, you know, for writing, and in a bad way sometimes people like copy paste it, and in a good way people like you know, use this for you know, compiling more information from the literature review or literature survey, for example. But there's actually many bad examples, like recently, that people use this artificial intelligence thing for like just you know, maybe it's gonna be like pollute the science by just like copy pasting, for example.
Well, I think you hit the nail on the head. The people who are using AI are divorcing themselves from the literature to some extent.
Yeah.
You know, they don't have to read the literature. Those citations will be put in there for them.
Yeah.
They become divorced from the learning process, which I think is a shame. And I'm not sure whether they're going to become very great scientists.
Yeah. I guess it's always about like how you could use it properly, but yeah, apparently there is some cases that they
I think
abuse
there's
it.
tremendous
Abuse it.
satisfaction in writing a paper yourself, in crafting that sentence, finding just the right word, a series of sentences that make sense in a paragraph, a whole organization of a paper that comes from your own thinking. I think there's tremendous satisfaction in that. And hopefully that won't be lost.
Yeah, I mean that's an amazing conclusion. All right, so yeah, I believe that we are as geologists are good in the field, are good in also in the papers and conferences. Like we so excited about showing our findings to our fellow, fellow college, like our colleges in the same field or the same discipline. But do you see that we are also we are good at delivering this complicated and maybe like not complicated, like it's not easily understandable for the public, like for the outreach. Do you think that we are good in that, like we like the non-specialists, they can digest our findings or our information from geoscience easily, or we need to do like a little bit of effort on that?
I think there's a lot of work that needs to be done. I'm not sure it's being done very well at all, and I'm unsure as to how to significantly improve our outreach. We need to ask the questions, how do we get people interested in geosciences, especially young people? I've asked my undergrads, I teach a class of 90 students in beaches and shorelines. I asked them if their curriculum in middle school or high school gave them opportunities to learn more geosciences. More than half the class said no. So we have a large percentage of incoming students to various colleges and universities who have not been exposed to geosciences, or geoscience is not part of the science program at that college or university. Not sure what the cure is. Perhaps we need to find ways of getting geosciences back into middle schools and high school curricula. The folks who do the best job at this of promoting their science is, of course, NASA. They have a huge marketing department advocating their programs, and they're very creative, such as turning data from the Webb telescope into beautiful colored images. We need to find ways of better selling our science and educating people in geosciences relevant to their everyday lives. For example, look at the West Coast. Prolonged precipitation is causing landslides in regions that are overly susceptible due to forest fires and killing the vegetation. Treating these issues and other environmental problems is tied closely to a knowledge of geosciences.
Yeah, yeah. Also, like it's been noticed in maybe in the recent years. I don't know the case in the States, for example, but in the UK, there is a study that just have been published this year about the decline in the numbers of the student that they enrolled in geoscience, courses, and they actually relate these reasons to that there is not like the public or the people, like they are not they didn't get how impact or how important to learn the geoscience, or what is the importance of the geoscience.
Well,
And also
I think
yeah
all of
I
it.
mean
I think some of it stems back to these games that came out like PlayStation, where people didn't need to go outside anymore. They could entertain themselves playing some game by themselves or with friends. So instead of exploring the woods or going outside and having a pickup game, a ball, and just being outside and enjoying the environment, they got more tied into not becoming acquainted with nature, environment, and environmental problems. So I think so. It started some time ago, and I'm not sure what the cure is.
But do you think also the media, like the governmental media or private media, they didn't like invite a lot of geoscientists into their programs, into talk shows, and compare with other like fields like chemistry, biology, like? Or do you think that we are a little bit ignored in this part, or like we are equally treated, like compared with the other fields?
I think other fields are better known and better appreciated. I sat down with the president one time at a university, and he said to me, "You know what? I've never thought geologists much as scientists." And I reminded him that they only brought one scientist to the moon, and that was a
Yeah,
geologist.
true.
He laughed and
Yeah,
liked the comment a lot.
yeah. I guess we all at the society, like a geology society, we need to work on that, or to get people pay attention to our role in the society. Um, so yeah, like for also the geoscience opportunities after graduating from the school, there are many challenges to secure like good opportunity. In your opinion, like why should one consider a career in geoscience today?
Well, obviously, I'm a little biased, but I think it's a fantastic career. Geoscience has given me a tremendously interesting life and rewarding career. I've traveled the world doing projects and going to meetings, been involved in some highly rewarding and transformative science, able to mentor some truly remarkable students and terrific people, and work with many fantastic colleagues. And I've also had the opportunity to take part in some extremely interesting adventures, such as living in an underwater habitat with Denny Hubbard in the Bahamas and in the Virgin Islands. I've explored giant sand waves in mini subs with Mike Fenster. I've scattered numerous oil spills from Alaska to Peru with Ed Owens and Mark Culp. For me, it's been hugely fun and a highly rewarding career. Also, as we know, global warming is causing sea level rise and increased storminess, both of which are impacting coastlines throughout the world, particularly in deltaic and coastal plain settings. 1/10 of the world's population live in low-lying coastal regions. For example, look at the East Coast. Almost every major city is situated in an estuary, harbor, or back barrier setting. During even minor to moderate storms, parts of these cities are increasingly becoming flooded. The impact that Hurricane Katrina had on New Orleans and Hurricane Sandy had in New York should be a strong wake-up call about the devastation that future hurricanes will wreak in our cities and coasts. And remember too, that Sandy was only a Category 1 hurricane and Katrina was only a Category 3. Larger storms will be coming. We have $3 trillion worth of real estate and infrastructure along the East Coast alone. We're going to need a large number of geoscientists to work with planners, managers to cope with global warming and sea level rise. I've only mentioned coastal regions, but there are many other areas on planet Earth where geosciences will be needed to address the other impacts of global warming. Yes, indeed, geoscience will be needed, and geoscience is a great career path.
Yeah, I mean, I totally agree with that. I guess if someone likes to travel a lot or to meet new people, geoscience is the good window for that. I mean, in my field, in my discipline or my research, for example, we more or less work under the context of geoarchaeology. I'm from Egypt. I work with a German professor, and our study area actually in North China. And I see also some fellows, like they work in Africa, for example, like to work on some human remains or like stone artifacts. And they actually have to travel a lot, like to, compile and gain more discoveries in like to help people understanding the past climate change, the past environment change, and how it connected to the human evolution, for example. So yeah, like it's an amazing career, and it's amazing like opportunity if you have graduated from geoscience field. Yeah.
Yeah, you're doing some really interesting research. I looked up some of the things that you're involved with. And there's lots of interesting stories out there. We just need somehow to engage the public.
Yeah. I guess the public needs to get clear like information or clear understanding with what we are doing, and then we will see maybe like many people could see this as attractive, and then we gonna see like many people involved in the geological projects in the future. Okay, I mean, that was a nice interview with Dr. Duncan today. I mean, thank you for coming. Thank you for joining us. And again, congratulations for this amazing award from Francis P. Shepard. And yeah, thank you.
Thank you for interviewing me.